All right, guys, welcome today. We're going to go over our information for today. We're going to talk a little bit about multiplying polynomials. Now, what I want you to do is I want you to go ahead and open up your first tab that says Distributive Property. Go ahead and open up your first tab that says Distributive Property. So you should have what I have up here on my board. So what you're going to look at is it's going to look and say where it says using this strategy when, we're going to write underneath that multiplying polynomials by monomials or by polynomials. Now, all that really means is that we're going to take some type of polynomial, whether it be a monomial, binomial, trinomial, or a multi-term polynomial, and we're going to take that and multiply it by another monomial or some other type of polynomial. This method actually works for any and all polynomials. So the one we're going to look at today is going to be a monomial times a trinomial. So I'm going to go ahead and rewrite that one. You guys can just look at it on your page. So what we're going to have is 2x, and that's our monomial, times the trinomial x squared plus 5x minus 2. So here's where I need your help, okay? This is what we call distributive property. Distributive property is when we take each part, when we take this first term and we multiply it times each part in our problem. So what we're looking to do here is we're going to take and distribute, hence distributive property, and we're going to distribute that to each term. And when we distribute, what do? Do we add, subtract, multiply, divide?
Multiply.
Multiply, very good. So we're going to multiply the number times the other number. So first we'll start with our coefficients. Our coefficients here we know are 2, and what's the understood coefficient in front of x squared? 1. So we're going to take and multiply 2 times 1, and when we multiply 2 times 1, we're going to get an answer of what? 2. So 2 times 1 is going to give us 2. Now when we multiply a variable times a variable, we have to add the exponents. All right? That's something we talked about a long time ago, a good while back. All right? So when we multiply exponents, or when we multiply numbers that have exponents, we take whatever the understood exponent is, and we add them together. So what's 1 plus 2? 3. So we're going to get x to the third power. So that should be our first term. All right. So once we do that, we are then going to take and distribute it to the next part. So next we're going to multiply 2x times 5x. So what is 2 times 5? 10, and that's positive 10, so we're going to write plus 10. And then we also want to take and add x to the first power and x to the first power. So what's 1 plus 1?
2.
So that's going to give us x squared. And then the last thing we do in this problem is we distribute the 2x all the way out to the negative 2. So if we distribute that all the way out to the negative 2, then we say what's 2 times negative 2? Negative 4. And then when we have just a variable and we have no variable in the other, we just write down the variable we have. So since we have x to the first power, we'll write down beside negative 4, x to the first power. Once we finish, we have our polynomial, and that would be our final answer. All right, so going back to this problem, like I said, should be pretty easy to distribute this stuff. We're just going to take and multiply each part to each term, okay? So we're going to take the 2x and multiply it to each part. Once we get our answer, we should be good. So this is only when we're multiplying a monomial times something else. So keep this in mind as you move forward. Let's go ahead and look at our next part. So in our next part, we're going to do a binomial times a binomial. This is going to be known as FOIL, all right? So let's look at a binomial times a binomial. So for a binomial times a binomial, or whenever we have FOIL, now understand, FOIL is not the method here. This is still distributive method, but FOIL is just saying that we're doing first, outside, inside, last. Technically, this is an acronym, okay? And you can see that acronym on the outside of your folder. So when we use this strategy, we're going to multiply a binomial and a binomial. So the only two times we use this one is when we have a binomial times a binomial. We don't use this for anything else. Just binomial times binomial. Now the example they give us out to our right is x plus 3 times x, 2x minus 5. So what we want to do with that is we want to actually distribute just two separate parts. Now here's how I like to do this. This is my version of doing it. You can do it one of two ways. You can actually take it and say x times 2x, that would be first times first. And then you can do outside times outside, so that would be x times negative 5. And then you can do inside, which is 3 times negative 2x. And then you did inside, so then you want to do inside or last to last. So that would be 3 times negative 5. So you could multiply them that way. And essentially what you're doing is just multiplying the x times the 2x, the x times the negative 5, the 3 times the 2x, and the 3 times the negative 5. But I like to break it down even a step further. So here's how I like to do the FOIL. I take each number in my first binomial, and I separate each term into two parts. So here my two terms is what? X and 3. So I just separate them into two parts. Then I take whatever my second polynomial was, in this case 2x minus 5, and I just write it down twice beside those two terms. So 2x minus 5 and 2x minus 5. So once I have that written down, I then distribute each part. So what I like to do is say x times 2x. So what would be x times 2x here? 2x squared. Very good. Looks like you guys are getting that. So that's going to give us 2x squared. Now, what about when I multiply x times negative 5? Negative 5x. Very good. Catching on really quick. Now, I just continue adding to that. So next, I drop down to my 3, and I say 3 times 2x is 6x. So that's going to be plus 6x. And then lastly, I do 3 times negative 5. So 3 times negative 5 is negative 15. So once I get all my numbers together there, I then look and say, can I combine anything? So is there anything in this problem I can combine? Negative 5 and 6x. Negative 5x and negative 5x and 6x. So I want to go ahead and combine these two numbers. And usually it's going to be the ones in the middle if I do it correctly. It won't always be that way, but most of the time it will. So since I have nothing to combine with 2x squared, that's just going to stay 2x squared. With negative 5 and 6, what do I get when I add negative 5 to 6? 1. So that's just going to be 1x or x. And then I have nothing to add to negative 15, so that just stays negative 15. Once I've combined like terms, I then have my answer of 2x squared plus x minus 15. All right, so if we're good with this, we'll go ahead and move forward. So I'm going to go ahead and delete this off. And we'll pull up our last example, which is going to be the box strategy. All right, and then the box strategy, we're going to actually do a binomial times a trinomial. So let's check this one out and see what we get. There we go. All right, so this will be at the bottom of your notes. And this is going to be a binomial times a trinomial. Now, when do we use the box strategy? All right, when do we use the box strategy? This one will actually be when we're multiplying any. Multiplying any polynomial. All right, we use this strategy when we're multiplying any polynomial. Now, in this specific case, you guys are right. We're multiplying a binomial times a trinomial. This is just one instance. You can do this with binomial times binomial, monomial times trinomial, monomial times monomial, monomial times binomial. I mean, the possibilities are endless. And no matter how many terms you got, this will always help you get it in the correct order so that you can work it out. So here's how the box strategy works. So here I have a binomial times a trinomial. So how many terms do I have in a binomial? 2. How many do I have in a trinomial? 3. So what I'm going to do is I'm going to create a box that is 2 by 3. So I'm going to draw my box. I want it to have 2 rows and 3 columns. Now, the reason I draw a 2 by 3 is because I have to match it up to the number of terms I have. So we'll start on the 2 side. So when we look at our polynomial 3x minus 1, we're going to write in 3x as our top part of our box, and then the minus 1 will be the bottom part. So we have 3x minus 1 on the side. Along the top, we're going to do the same thing, but with our trinomial. And we're going to write x squared. Then we have minus 2x, so that's a negative 2x. And then a positive 7, which means this is a plus 7. Now, once we have this laid out, it's really just multiplying the cross sections. In other words, we're going to multiply where these two numbers cross. So if we were to look at 3x and x squared, they are going to cross in this first box. So what we want to do is we want to come up with an answer when we multiply those two things together. So let's start by multiplying the coefficients. What's 3 times 1?
3.
3. What's x times x squared?
X cubed.
X cubed. Remember, we always add the exponent. So we have 3x cubed. And we would do this for everything. Let's go ahead and do the bottom box here. So what is going to be negative 1? What's negative 1 times x squared? Negative 1x squared. We'll go ahead and write the 1 in here. Next, we can move over to our next column. So that's going to be 3x times negative 2x. So what's 3x times negative 2x? Negative 6 what? X squared. All right, we have 2 x's there. So when we add the exponents, we get squared. And then we have negative 1 times negative 2x. So what's negative 1 times negative 2x? 2x. Very good. And then over on the end, we're going to have 3x times 7. So what's 3x times 7?
21x.
21x. And then the last one, we have negative 1 times 7. Negative 7. Very good. Now, once we have it laid out, this is like everything's set up for us. Now, not always, but normally, they're going to add diagonally. So like here, what I like to do is I like to see what I have in common. So do I have any x cubes in this problem? No. So I'm going to go ahead and write that down. 3x cubed. All right. Do I have any? How many x squareds do I have? 2. So I'm going to combine those. So what's negative 1 plus negative 6? Negative 7. So that's negative 7x squared. Next, I'm going to do my x's. Do I have 2 sets of x's?
Yes.
Yes. So what's 2 plus 21?
23.
23. And that's 23x. And then I have a negative 7. Can I add anything to negative 7? No. So I just write negative 7. And then when I'm finished with this, I see that my problem is going to be a little bit longer. It's actually got 4 terms in it. So this is considered a polynomial. But I have my answer simplified all the way down, and it's already written in standard form for me. So like I said, you're always going to have your first and your last terms, and then normally, not always, but sometimes, you're going to combine these terms diagonally if those variables match up. Okay. So does anybody have any questions about this? Okay, pretty good. All right. So like I said, the notes are videos, so you'll be able to access those. I'll get a Google Classroom together so that you'll have that. And we can talk a little bit more about that later on in class. Good job today.